Hi, in this video we're going to continue with writing domain and range graphically. So let's take a look at this graph here on the right. It looks like if we look at our domain, remember it's always left to right, and we are looking at all our possible inputs, which are x values. So we could see that there is nothing left of 8, and the domain is starting basically at this point 8. And then it is extending to the right. So this arrow just means it's going to keep going in this direction, and it's just going to extend and continue this way. So even though I don't know what the equation of this graph, I can certainly write the domain. And the way we would write it is we could use different notations. We could say that x is greater than or equal to 8. And of course, all real numbers. So when I draw this double line with this fancy R, this indicates all real number. What is all real numbers? Well, X is an element of all real numbers. So this little rounded E means element. So X is an element of all real numbers where X is greater than or equal to 8. All right, so let's take a look at Delta Math and the options we are given. So the first thing we're going to do is we're going to see the answer type, and it gives us interval, all real numbers, all values except 1, or all values except 2. Well, in this case, it's not all real numbers because we start at a particular number 8, so we're going to use interval. And the notation we can use, we can either, like I showed you in the last video, use brackets, either rounded or square, depending if it's inclusive or not. Now, because I'm going to the right, anything going to the right, let me just explain this. If I were to draw anything going to the right is infinity, and anything going to the left is negative infinity. Okay, same thing with up. Anything going up forever is infinity, positive infinity. Anything going down is negative infinity. So you can see the options here in our little squares. They have negative infinity, infinity. Now this symbol right here means union, and I will explain that in a moment. So if we were to write the interval here, because it's starting at 8, I'm going to use a rounded bracket, a square bracket, but because it goes forever to the right, I'm going to use a round bracket because anything going forever to the right doesn't end, means you put a round bracket. You cannot close off infinity. So the first lower bound, remember we always start with the lower bound, is 8, and then it goes forever to the right, so that would be positive infinity. Let's go ahead and see the notation they give us, and let's look over here, the different notation. So we did get that right, of course. So the number starts at 8 and goes to infinity. So the domain is square bracket 8, comma, infinity, rounded bracket. As I mentioned, you cannot close off infinity ever with a closed bracket. It's always a round bracket. Another alternative notation is just to write x is greater than or equal to 8. So let's go ahead and look at another example. Okay, new problem. Let's see what we get. So if you were to look at this, it appears we have an asymptote. So let me draw this in. So for example, the graph is going down forever and then it extends to the right. So if I were to draw a vertical asymptote, let me draw to see where that vertical asymptote is. It looks like I have a vertical asymptote at x equals 2. Okay, so even though it looks like this graph will touch 2, it is coming towards 2 but will never touch it. So we have a vertical asymptote at x equals 2. Now because we have a vertical asymptote at x equals 2, that means the domain cannot equal 2. That means x can never be 2. So again, because I have a vertical asymptote at x equals 2, it means that the graph will never touch 2. Now remember, when we want to write our domain, we want to know what possible inputs are available for our graph. So let's take a look how we would write this. So we can write x is greater than 2. So one possibility is x is greater than 2, not including 2. It does veer to the right, so we can also say, because it starts at 2, a round bracket starting at 2, comma, and then going to the right, that would mean positive infinity, round bracket again. So let's go ahead and see how we would write this using our interval. So I would go ahead and write, see the way they would like us to write this. So I would write 2 rounded brackets. So starting at 2 and going to the right to infinity. Okay, let's go ahead and see what happens when we submit this. All right, so taking a look at the graph, everyone. So again, the graph starts at 2, but not including 2, and goes to positive infinity, means going forever to the right. So the domain is 2, comma, infinity, using round brackets. Another way we can write this is x is greater than 2. And that is pretty much it. Let's try a different one. Okay, this is familiar to us. All right, here is a rational function. And even though we don't know what the equation is, we can certainly see that we have an asymptote. Where is that asymptote? If I drew a vertical line, it looks like the graph is approaching -1. So the graph has a vertical asymptote at -1. So my vertical asymptote is the line x equals -1. Now you do want to mention when you write an asymptote that it's x, because we can also have a horizontal asymptote. But right now we're only interested in the domain, and the domain means all possible x values, all possible inputs. So we have a restriction for the domain. That means the domain that x is an element of all real numbers, but this little e means element, and this double line with the r is real numbers. And then we can say where x does not equal to -1. So what would be the notation we can use? So there's different ways we can use this. Let's see how we can write the answer type. All values except 1. I'm going to go ahead and use this because x is actually all values except -1. So let's go ahead how we can write this. X, so this notation, basically the way I would read this is x such that x is an element of real numbers, r, where x does not equal to -1. And I'm sure when I submit this, we could see alternative methods to writing the domain. So let's go ahead and take a look at the alternative methods. So first of all, we have an asymptote at x equals -1, as I mentioned. The domain can be written in different ways, okay? So the way that's easiest for you is the way you should write it, but you should be able to understand each notation. So first of all, the domain is a set of all real numbers given that x cannot equal to -1. So this is the first one. It says all real numbers except -1. All right, let's look at how they wrote it using brackets. They actually use rounded brackets. So what this on the left represents means because we start with our lower bound. So it goes to -infinity here, as you can see. in this direction. You're going forever to the left. And then you have an asymptote at -1, but it will never touch 1. So this is what this side is. It's saying it goes from -infinity to -1. This symbol here means union. So you can see it. Union, meaning adding on to. Now let's look at the right side. The right side, we start at -1. So here is my right side. We begin at -1, but not including -1. And then we continue forever to the right. So that's positive infinity. So this is a different alternative to writing the domain. This one right here. All right, let's look at another way to write the domain. So another way to write the domain is x is less than -1 or x is greater than -1. Both will work.